This slide you're going to have to take a little bit on faith, but let's break it down. Here's another bone. You could see the spicules again, and you could see a lot of bone marrow between the spicules. If you remember, we said in general, even red marrow or hematopoietic marrow is about 50% fat. I think you'll agree that the fat here is just a very small percentage of the hematopoietic marrow, perhaps 10%. So first of all, we have an increased cellularity. The other thing that we're going to see, and not as nicely as we'd like to because this is a tissue section rather than a smear, is that whenever you see little groups of cells like here, these are all erythroid cells. Here, 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 here. You could see that the majority of cells within this field are erythroid cells. That's also unusual because there should be 3 times as many myeloid cells as erythroid cells. Or in other words, the ME ratio in a normal marrow is about 3 to 1, but in this case, it may be reversed. It may be 1 to 3. So the two things we could say without going into the fine cellular detail at all is that number one, there's an increased cellularity because the fat is a heck of a lot less than 50%. And number two, rather than the erythroid cells being only about 1/3 of the hematopoietic cell population, it's a heck of a lot more, perhaps even a reversed ratio. It's certainly more common than the myeloid cells. So those are just the two things I want to emphasize, and we don't have to go into anything fancy right now. Hypercellularity and erythroid hyperplasia. That's why this slide is called bone marrow erythroid hyperplasia, and thank you very much.